Okay, the quarterly review. I've made some questions here that should help you study. It basically comes down to three main topics for quarter one, right? Functions, slope rate of change, and sequences. There's a lot of those things that we're going to review in this video. To keep in mind, some questions are going to be multiple choice. Some questions are not going to be multiple choice, but the math idea behind it is what is important. So let's get into it. Number one, tickets to a local fair cost $25 for adult admission and $15 for student-child admission. Let A be the number of adult tickets sold. Let S be the number of student or child tickets sold. The fair sales totaled 4,850. Write an equation of the model situation. Well, basically, what this is the number of adult tickets, right? Adult tickets sold plus the student-child tickets sold was equal to all this amount of money, right? $4,850. But it was $25 for each adult ticket, and it was $15 for each student ticket. So an equation would be 25A for 25 for each adult ticket plus 15S. Hopefully you can tell the difference between a 5 and an S there. 15S for $15 per student child ticket to equal $4,850 would be your equation. And it's pretty intuitive. You have your adult tickets plus your student child tickets and the price for each of them equaling $4,850. Okay? And that's it. That's the equation. Number two, f of x goes through the point 2, 5 and has a slope of -2. G of x represented by the equation g of x equals 3x plus 7. What would really help us here is if we do what we did recently, which is make an equation for this information, right? Make this f of x, an mx plus b. We know y is equal to mx plus b, but this is going to be for f of x. I'm just going to use f of x instead of y. But same idea, right? mx plus b. Okay. So this equation, we know that the slope of this line would be -2, so that is our m value. We don't know b, so we'll have to use what we have here to find b. Now what we have is 2 is an x value, 5 is a y value. So I have an m, an x, and a y that I can plug in to y equals mx plus b and try to find out the mystery b. So if I do that, then I'm going to use this 5 for y. I'm going to use the -2 for the slope, the m. I'm going to use this 2 for the x, and then solve for b. So what I end up with is 5 equal to -4 plus b, and then we'll add 4 to both sides. So adding 4 gets me 9 equal to b. So now I know the equation. I know m is -2. I know b is 9. So our equation for f of x is f of x equals -2x plus 9. Let me fix this right here. -2x plus 9. Now we can use this and compare it directly with g of x. And then we can look at the answer choices. So f of x has a greater slope than g of x. Well, f of x's slope is -2. G of x is 3. We can see that's not true. And you can go through the options. The f of x has a greater y-intercept than g of x. In this case, that's true because f of x y-intercept is 9 and g of x y-intercept is 7. So, we can say that that's true. F of x has a smaller x-intercept than g of x. Well, we didn't really have anything to find the x-intercept. So, if we see that, we'll just kind of skip it. And f of x has a smaller value than g of x at x equals -2. Well, if that's true, we can just plug in -2. So for f of x, if I plugged in -2, it would be -2 times -2 plus 9, which would be a 4 plus 9, which means that f of x would be equal to 13. If we try the same thing with g of x, if we plug -2 in, it would be 3 times -2 plus 7, which would mean that equals -6 plus 7, which equals 1. So this is saying f of x has a smaller value than g of x. Well, that's not true. F of x had a bigger value than g of x. So I think the only one that was correct here was b. But you never, that's what you need to look for. Idea here is definitely, if you see a question like this, make f of x the equation for f of x, and then you can much easily kind of understand which answer choices would be correct and which answer choices would be incorrect. So make the equation for f of x. You know how to do that. Remember, it's just slope-intercept form. You have your m is -2. You have a y in 5. You have an x in 2. You have all these things. Plug them in, find b, and then make the equation. Okay? Number 3, which of the following points lies on the graph 3x plus 6y equals 6? Now, it's going to be, this one's select all apply for my review. Basically, how we can check if which point or points, could be one, who knows, lies on that graph is which xy fits in the equation. So essentially, we'll test out each of these and we'll see which one fits or in which ones don't. So let's try A first. So 3, I'm going to plug x as -2. So I'm going to plug x -2 in for x. I'm going to plug the 2 in for y, plus 6 times 2 equal to 6. Now this comes out to be -6 plus 12 equal to 6. And this is true. -6 plus 12 does equal 6. So that point belongs. So A would be an answer choice, right? And that's what we're going to do for all these other points. So continue plugging in x and y. So we're going to plug 2 in for the x on the next one and 1 in for the y. So this is testing option B. What I get here is 6 plus 6 equal to 6. Now that's not true because that would be 12 equal to 6, which is incorrect. So that one is a no-go. That one does not work. We'll try C, which is 0, 1. So 0 for x, 1 for y. That would be 0 plus 6 equal to 6, and that is true. So that one works. So C would be a good answer. Now we can plug in the option D. 4 in for the x, -1 in for the y. This would be 12 plus -6, or basically just 12 minus 6 equal to 6. And that's true, right? 12 minus 6 is 6. And that, of course, equals 6. This is a true statement. So that one is good. And then, we can plug in the last one. Plug in 6 for the x, 3 for the y. And this is 18 plus 18 equal to 6. And that's just wrong. That's 36 equal to 6. That's not true. So basically, it really just comes down to, putting the x and the y in the function and just seeing what is true and what's not. So just plugging in those numbers. For each graph, write an equation to match. So we're going to write our equation again in y equals mx plus b form, right? Slope-intercept form. So what I want to see from these graphs is what's the slope and what's the y-intercept. So looking at, the first graph, we see the y-intercept is at 3. And our slope, we kind of have to read into it really closely. This slope looks like, there's a point clearly here, a point clearly here. You kind of have to look for those matches. And if I count this correctly, if I go from this point up to this point, that would be rising 3 and running 2, making the slope, remember slope is rise over run. If I rise 3 and run 2, it makes my slope 3 over 2. So an equation for number 4 would be y equals 3 over 2x plus 3, because our y-intercept is 3, as we can see, so that's the reason for that number there. And our slope we counted as up 3 over 2, so our slope was 3 over 2. And just like that, right? We can do that for the second and third graphs. So we have the y-intercept is 7 for the second one, and our slope, if we look carefully, looks to be, these points. All right. So what we see, if we count that down, that's going to be a rise, actually going down 1, right? Going down 1 and right 2, making our slope, if we're going rise and run, our slope in this case would actually be -1 as our rise, since we have to go down 1, and then run a +2 since we go right 2. So that would be our slope. So our equation, our slope is -1 over 2. Our equation is y equals -1 over 2 x plus 7, since 7 is the y-intercept, and -1/2 is the slope. And then look at the last one. The last one has a y-intercept of 5. And then if we pay attention, our slope, if we kind of look at these points carefully, try to map this out, it looks like those points would be rising 2 and running 1 to get through this graph. So a rise of 2 and a run of 1 tells me that my slope is 2. So an equation for this, remember the y-intercept is 5. The equation for this would be y equals 2x plus 5. 5 was the y-intercept, and 2/1, or just 2, was our slope. So look for those graphs, note your slope and intercept form, should help you. Number 5, if the points 4y and x6 are the solutions of the equation 2x plus 4x 20, what are the values of x and y? So this is very similar to number 3, where we're just going to plug in numbers, right? So essentially, this right here is saying that the x value is 4, so what's y, right? If we want to find out what that y is, well, then let's plug in that 4 for x, right? The equation is 2x plus 4y equal to 20. So this point is saying that x is 4, so I'm going to plug in 4 for the x, right? And then now I can solve for y. So this would be 8 plus 4y equal to 20. We'll subtract 8. We'll have 4y equal to 12, right? And then divide by 4. We end up with y is equal to 3. So this y value would be 3. And then we can do the same process for the other point as well. This x and this y, they don't go together. They're part of separate points. The y is part of this point, but now we're looking for the x on this separate one. So, but even though I'm looking for x here, because I don't know what it is, I do know that the y value is 6. So I'm going to plug it in, right? 2x plus 4 times 6 equal to 20. And then do the math. So this would be 2x plus 24 equal to 20. And then we'll solve, right? We'll subtract 24 on both sides. We end up with 2x equal to -4. And then divide by 2, we end up with x equal to -2. So the x value of that point would be -2. So the y value would be 3. The x value would be -2. So again, it's about plugging in your numbers and finding what you need. Plugging in the 4 for this x, plugging in 4 for the x, and then figuring out y, and then doing it again, but plugging the 6 in for the y and solving for x. We get those answers. All right, so number 6, use the table below, write an equation that can be used to model the total distance in y miles for x days. Okay. Now remember your equation, right? Y equals mx plus b. Okay, this is very important for this one. All right, m, remember, is slope, and b, remember, is y-intercept. Now, from this table, we can find out the slope pretty easily because every day that we go up, right, we increase by 3, right? So our slope is essentially 3/1, or just simply 3, right? Every day that passes, it's 3 more miles. So this is the m value, and we can kind of just see that because we notice the change in those y's, right, relative to x. So we know that the slope there is going to be 3. Now, how do you find the y-intercept? That's tricky. Well, you can do what we've done in the past, which is, use one of these points, plug in this 3 for the x, this 24 and for the y. You can do that. That actually might be a good idea. That's not the way I was thinking about doing it, but it could work, right? So let's try this. Let's try using this 3 as x and this 24 as y, right? So if we do that, we'll have 24 for the y equal to the 3 for the slope, because remember we just calculated that the slope was 3 from all of these. But I am going to use this 3 for x, so I'm going to plug in another 3, right? This was the m, this was the x. I know they're both 3, but anyway, right? And we can solve for b. So ultimately, I end up with 24 equal to 9 plus b. I can subtract 9, and I end up with 15 is equal to b. So now I know the equation, right? The y-intercept would be 15 Well, I already know that the m value of the slope was 3, so my equation would be y equals 3x plus 15. Now here's another way of doing it. Another way of finding the y-intercept is working your way backwards, right? Because you have a table. So let's say, what if you found out, what if you kind of went backwards, right? 2 days, I'm going to write over this, so don't mind me, 2 days, and we would subtract 3. 2 days would be 21, right? Go backwards again, 1 day, go back another 3. 1 day, that'd be 18, right? Because you're subtracting 3 because you're kind of filling the table in backwards, right? And then the point is to get the 0 days, because 0 days would be the y-intercept. And if we go back 3 one more time, right, then 18 minus 3 would be 15. So if we fill in the full table starting at 0, it would be 0, 15, 1, 18, 2, 21, 3, 24, 4, 27, 5, 30, 6, 33. So you see what I'm saying? Like the full table would read 0, 15, 1, 18, 2, 21, 3, 24, 4, 27, right? And so on. I'm just repeating the pattern that I noticed in the table, and I'm just working it backwards until I got to 0 for the x. Because when x is 0, this is going to be my y-intercept. So that's another way of doing it. We've never talked about that before, but that's kind of how I thought about it when I first read the problem, was just sort of, what if I just work my way backwards, right? And I find out what the y value is when x is 0. But like I said, the other alternative is just take an x value and a y value and your m value and plug those all in. That can work probably even better. I don't know. It's up to you. Number 7, which of the following points is a solution of the linear equation represented by the graph? Now, I'm not writing the equation here. I mean, you can if you want to, but you don't need to. Basically, I should have added points to this, but what I'm asking for is, what points essentially do you see on this line, right? So look on this line and look for points. So let's say if I say, hey, is the point 4, 3 on this line? The answer is no, because the point 4, 3 is here and it's not on that line, right? What about the point 2, 5? Is the point 2, 5 on this line? Well, if you go to the point 2, 5, you'll know it's not on the line, right? So I should have thrown that in there before this, but anyway, you're going to see questions like that, right? What about the point 3, 3, right? Is that on there? Well, if you look at it, it actually is, right? 3, 3 is on the line. It works. So when you're asked a question like that, which of the following points is the solution for the graph? Basically, all you're looking for is what points are on the graph. So if this was a multiple choice question, A, B, C, whatever, right? You're essentially just looking for which one of the points is actually on the line. There's a lot of points on the line. 6, 8 is another point on the line. So just go through your answer choices, see which points end up being on that line. Okay, number 8. Now we're starting to do rate of change, right? Slope problems. So there's a lot of this you need to be able to know how to do. So find the average rate of change between day 1 and day 5. Now what that means, day 1 is this point, right? 1 and 0.2. Day 5 is this point, right? 5 and 1.6. So when it's asking for the average rate of change, you're just doing your slope formula. Remember, difference in y over difference in x. So subtract the y's, subtract the x's, right? Y minus y, x minus x. So let's do that. Let's do y. So again, this is x, y, x, y. So let's subtract the y's. So 1.6 minus 0.2, because those are the two y values, right? And then subtract the x values, right? 5 minus 1. So 5 minus 1 is, all right, so let's do the math. This comes out 1.6 minus 0.2 would be 1.4, and 5 minus 1 would be 4. So there's your slope, essentially. If you want to calculate that, 1.4 divided by 4, do I have a calculator? I don't know if I have a calculator. All right, so 1.4 divided by 4 is 0.35. So a slope of 0.35. There's your answer, right? Remember, it's just subtracting y, subtracting x's. You got a whole table here. But the question's only asking you to focus on 2 points. It's only asking you to focus on day 1 and day 5 points. So the rest of this information doesn't even matter, right? You're just subtracting the y's for those points and the x's for those points. And we're going to do the same thing on part B, right? Part B is asking for 2 different points. Let me erase. Okay, part B is asking from day 3 to day 6. So day 3 is 1.1. And day 6 is 2.8. Right? Ignore everything else. It doesn't matter. We're only finding the rate of change between these 2 points. So we're going to do the same thing. Subtract the y's, subtract the x's. So y minus y, that would be a 2.8 minus 1.1. And subtract the x's would be 6 minus 3. So when I calculate this, this would be 2.8 minus 1.1 would be 1.7 over 3. And then calculate that. 1.7 over 3 is 0.5667 or 0.56 repeating, if you will. Okay, so there's your slope. So remember, you're going to see this a lot, but only focus on the days it's asking for. I can't stress that enough. You do not have to find the rate of change between every single thing. Like, you don't. You only have to do it for the days that's given, okay? Please, please, please only use the days that it gives you. We're going to see another one. I think the next problem is just the same exact thing, right? So number 9. Calculate, interpret the rate of change from 2 to 4 hours. So we have our table represents hours, gallons, drained, whatever, right? Interpret the rate of change from 2 to 4 hours. So 2 is 15,000 and 4 is 12,750. So we're just finding the rate of change between those 2 points, right? So ignore the other points. They don't matter, right? Remember, rate of change, just difference in y's over difference in x's. So when we subtract, we can do the second minus the first. So 12,750 minus 15,000. So this y minus the first one. And then x's, do this x minus this one. So 4 minus 2, right? Subtract the y's, subtract the x's. So when I calculate that, that'll be 2,250 over 2, which is, again, using a calculator here, 2,250 divided by 2, which is 1,125. 1,125 is the rate of change just between those 2 points. Not for the whole thing, but just between those 2 points. Okay? And repeat this process for the next one. This is between 2 and 5 hours. So 2, again, was 15,000. And 5 is 11,250. So same idea. Subtract the y's and then subtract the x's, but only for those 2 points. Don't worry about the other points, okay? Only focus on those. So if I subtract the y's, we're going to do the bottom minus the top one. So we'll have, 11,250 minus 15,000 over the 5 minus the 2. So when I'm calculating that, this would be 3,750 over 3. So again, handy calculator. Oh, messed up. 3,750 divided by 3 is 1,250. So there's your rate of change for B from 2 to 5 hours. So again, only use your slope formula, right? Subtract the y, subtract the x's, but do it for only the points that it gives you, okay? 2 hours and 5 hours. That's those 2 points, okay? If it was 2 and 4 hours, then it's only these 2 points. So please, please, please don't do more work than you have to. Just do the ones you need, okay? Let's keep going. All right. What is the average rate of change between 1 and 3? This, okay, very same question. Is this broken? Did I mess something up here? I don't know. Very same question, okay? But again, we're looking at the points at 1 p.m. and 3 p.m. Only those, right? So at 1 p.m. we have the point here, which is, we'll say 1 o'clock and 50, because that's about 50, right? So we have that point, and then the one at 3 p.m. The one at 3 p.m. is up here, which is 3 p.m. That's about 175. So again, only using those 2 points, right, find the rate of change. So subtract those y's, subtract those x's. So let's do the other way around. Let's do the 175 minus 50 as my y's, right? My y minus my y. 175 minus 50 over the 3 minus 1. 3 minus 1. So again, just those points, okay? Ignore everything else. Don't worry about the curvature of the graph. That does not matter at all. You're only focused on those 2 points, the x values, the y values of them, right? Please don't do any more than you have to. This comes out to be 125 over 2, which is, what's 125? Like 60 something? 125 divided by 2 is 62.5, okay? 62.5. So there's your rate of change, okay? Please, again, do not do more than you need to do. Please. So rewind that, rewatch that if you have to. I'll say it one more time, though, just in case, right? Between 1 p.m. and 3 p.m. So 1 p.m. was 50, 1 p.m. 50, right? 3 p.m. 3 p.m. was at 175, 175. Just subtract the y's, right? 175 minus 50, subtract the x's, 3 minus 1, right? Just simplify that math. That's all we're doing, okay? Now, sequences, right? A function that represents a sequence. Hint, use the explicit formula. Remember, when we wrote this, we wrote f of x. You did terrible on this test, by the way. But anyway, f of x equals blank plus blank n minus 1, right? This was for the first term. This was for the common difference, right? That's what f of 1 means. F of 1 means first term, and then d means the common difference, which is the difference in the problem. So if you look at this table, right, we can see that the first term is 14, and then our common difference from number to number is plus 8. So that's all we need to make our equation. Our equation would be f of x equals 14 plus 8 n minus 1. That's our answer, okay? We're following that function. Now, you're going to have to remember that function, okay? That's your responsibility. Blank plus blank n minus 1. But if you remember it, it's very simple to just plug in, hey, you're looking for your first term, well, that goes here. And then you're looking at your common difference, and that goes here. And you've got your equation. It's very straightforward. Okay? So make sure you're able to do that. That's important. All right. Number 12, Ronnie is saving money for a new guitar. His parents gave him $200, and he plans to save $45 each week from his job. Write an explicit function for the arithmetic sequence where n minus 1 is the initial value. So the sequence here, if you actually want to write it out, you can, right? It starts with $200 from his parents, and then he adds 45 every week. So if he adds 45, the next time would be 245. If he adds 45 again, the next time would be 290, right? Because you're adding 45 every week. That helps, just to kind of illustrate the point here. Now you're writing a function, right? An explicit function. So same formula, f of x equals blank plus blank n minus 1. Remember, this is going to be the first term. This one's for the common difference. Now, the first term is going to be 200 because that's what his parents gave him. That's what he starts with. His savings starts with that. And the common difference is going to be 45 because he's earning 45. Now, if we're n equals 1, yeah, that's right. So this is correct. N minus 1 is good there because n equals 1 is, okay, yeah, this is what we wanted. It's basically, just don't mind that too much, okay? Just worry about the fact that it's the explicit formula, right? F of x equals the first term plus the common difference, n minus 1. Remember that formula and remember how to plug those numbers in or where those numbers go, what they mean. Okay? That's all we're doing. Piece of cake, right? Let's hope. Okay, great. All right, and then number 13, last one. Very tricky question. But what we need to do is, write out numbers. Write out numbers, okay, when you see something like this. So you'll notice the first one has just one square, right? The second one has 3 squares, right? The third one has 5 squares, right? The fourth one has 1, 2, 3, 4, 5, 6. Wait, did I do that right? No, I miscounted that. 1, 2, 3, 4, 5, 6, 7. 7 squares, right? So look at what the pattern is, right? And then write your function out. F of x or f of n, whatever it was. I think when we did it was f of n, but anyway. Yeah, it was definitely f of n. I don't know what I'm writing x for. Oops, that should be an f of n. Okay, doesn't matter, right? Remember, first term plus common difference, n minus 1. So our first term would be 1 here because our first term had 1 square in it. Our common difference is plus 2, right? We're adding 2 every time. We're adding 2 squares every single time. So our common difference is 2, and there's your function, just like that. Okay? So it shows you these shapes, but don't let the shapes freak you out. Turn the shapes into numbers. 1, 3, 5, 7. Because then it's a lot easier to understand. It's a lot more straightforward. You can see the first term, you can see the common difference, and it makes a lot of sense. You plug the first term in, plug the common difference in, and you're good to go. Okay? Let me give you another example in case shapes freak you out. I'm going to give you more shapes, All right, so let's say I have this, right? I've got that one. I've got this one. I've got this one, right? And then maybe a fourth shape, right? This one, right? I see shapes, but just remember, count. Put numbers for these shapes. So if I'm trying to write a sequence, if I'm trying to write an equation for this, right? Let's turn it into numbers. The first one is 4. The second one is 6, because remember, 4 squares, 6 squares. The next one is 8, and this one is 10, right? So turn it into numbers. All those pictures, they just really mean 4, 6, 8, 10. And you can make a sequence out of this now. F of n equals, well, our first term is 4, and our common difference is plus 2. You're adding 2 every time, right? N minus 1. There it is. You've made your equation. Okay? Yes, they always end in n minus 1. Sequence formulas do. It's just you have your first term, you've got your common difference. And then again, ends in n minus 1. So don't let shapes freak you out. They look confusing and all, but really just turn them into numbers. That's the most important thing I can try to explain to you. Turn them into numbers. And then that's it. Hopefully, you know what you're doing now. If you have questions, let me know. Ask me right before the test tomorrow or whenever you take it. If you have questions on any of this, I'd be happy to try and explain it in person. But that's going to be it. Good luck. Rewind it. Go back over anything that you need to. If you can do everything here, if everything makes sense, if you found this all easy, you're going to be great. I hope you guys, do well. Wish you luck. See ya later.